Okay, geometry folks, we are back on the unit for proofs, basically, and we're going to move on to the next section in the textbook about proving angles congruent. I'm just going to do a run-through on what's missing from the PowerPoint that I have. So again, this is an addendum to a PowerPoint that has a bunch of notes with vocabulary lessons. And basically, we're going to cover some more things about theorems and proofs and with vertical angles and all that stuff. So we're going to be proving angles congruent. That's basically the deal. So like I said, there's a PowerPoint on Edmodo. I'm just going to supplement that thing. And so we're going to get into one of the parts of the PowerPoint, which is this proof. We're going to have a proof that vertical angles are congruent. And so we have to know the difference between a theorem and a postulate. A postulate is basically a vocabulary piece. It's like a thing that is, right? That's a postulate. A theorem uses an if-then statement, like a hypothesis and a conclusion. So if this, then that. That's the difference between a postulate and a theorem. But anyway, we go over that in the PowerPoint a little bit. But here's a proof. And so you remember how proofs work. The old two-column proof is what we're going to use. And so how's a two-column proof work? Well, we have our statement and our reason. Okay, so we have a statement and a reason for our two-column proof, and that's what we're going to use here. First, let me tuck in some stuff underneath here, make it easier to write on. So we're going to use that for this vertical angle theorem. So we look at this diagram, and what's given is that angle 1 and angle 3 are vertical angles, and so we're going to prove that angle 1 is congruent to angle 3. How in the world would that work? So we have the statement. So normally with a proof, what you want to do is start with the given thing. So the statement would be, well, angle 1 and angle 3 are vertical angles. And the reason for that, well, it's given to us, right? It's given. So the reason we would say, well, that's given. I'll use red for my reason. Hopefully it shows up pretty well in the video. All right, so that's given. Okay, so that's the first thing to start. Now we start wondering, well, what else can we talk about, right? What can we talk about in this picture? And when we start looking at the picture, hopefully we see another vocabulary thing. So what's cool about this thing that's going on? What's cool about this diagram is hopefully you see this piece of vocabulary from before. You can tell something about angle 1 and angle 2, right? There's something cool about those angles. And we can say that angle 1 and angle 2 are supplementary. And then you think, well, wait a minute, how can we jump to that conclusion? How can we jump to the fact that angle 1 and angle 2 are supplementary? Because they form a linear pair. And so the definition we would use for that, or the reason we would use for that, angle 1 and angle 2 are supplementary. How do we know? Because that's the definition of a linear pair. Right? So we would say definition of a linear pair. And we can use that as a reason because, well, that is a reason. Okay, so we look at the diagram and we see, okay, well, we can do something with that. Angle 1 and angle 2 are supplementary. They're a linear pair. And now, what do we do with that piece of information? So what do we know about that? We can say this. Well, then the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And you'd say, well, how can we jump to that conclusion? And the reason for that statement, well, that's definition of supplementary. Okay? So now what we're using is, we're using the vocabulary of linear pair. Now we're using the vocabulary of supplementary. So we'd say definition of supplementary. Okay, or definition of supplements. Supplementary angles add up to 180. Okay, so we have this established, this neat little mathy thing going on for angle 1 and angle 2. So that's as far as we can get with angle 1 and angle 2. Then you look back at the diagram, what else is going on here? Take a look at this. We have another linear pair. So we have this other linear pair thing going on. And what's kind of fun / frustrating about proofs is that you go through all this writing about angle 1 and angle 2. Now you got to do the same exact thing for angle 2 and angle 3. So we notice the same thing about angle 2 and angle 3. So look how we wrote here for angle 1 and angle 2. We're going to do the same thing for angle 2 and angle 3. Right? So angle 2 and angle 3 are supplementary. You know, well, how do we know that? What's the reason for that? And again, we could look. They're a linear pair. They're adjacent angles that make a straight line, and so that's the definition of a linear pair. Okay, so we can say definition of a linear pair. The same way we did for angle 1 and angle 2. And so now what's going to follow is the same exact thinking. Okay, well, if we can, oh, I didn't mean to put measure there. So let me, boop, boop. If you caught that. Good catch. Okay, so just angle 2 and angle 3 are supplementary by looking. Now we can talk about their angle measures. Be careful, cats, right? You too, kids, be careful. So now that we established that angle 2 and angle 3 are a linear pair, they are supplementary. So we can say this. Well, the measure of angle 2 plus the measure of angle 3 is equal to 180. And the same reasoning we gained before for definition of supplementary, we could use that again. All right, a lot of definitions. So we can say definition of supplements, right, or supplementary. Angles, by the way, I should put supplementary angles. Let's be precise, Mr. Katz. All right, so we should put angles there, FYI. You should be precise. So definition of supplementary angles, definition of supplementary angles. And so now we have this thing set up, okay? So we've taken what we can from the picture. Now let's look at what we're doing here. Isn't there something interesting we can do here? Hang on for an announcement.
Attention, Cougars. At this time, we need everyone to exit campus through the iron gates unless you are with a supervised faculty administrator. If you have a supervised faculty administrator meeting, you deal with that person at this time. All other students, please exit through the iron gates and wait for your ride there. Hope everyone has a lovely afternoon, and we will see you back here for Short Day Wednesday, the greatest day in education.
Okay, so we can see here through the announcement, hopefully you saw what I was pointing to. If we have the measure of angle 1 and the measure 2 is equal to 180, and this is also equal to 180, which is the measure 2 and measure of angle 3, we can totally establish that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. And Mr. Katz, how do I even think about that? Well, you got to look at patterns, right? You got to look at things going on. Once you take what you can from the diagram, you look at what's happening in your statements to see if you can play around with anything. So how can we say this? Hopefully you remember, this is the transitive property of equality, right? If A equals B, B equals C, then A equals C. So we can completely say, because the transitive property of equality, that we can cut out the middleman equality, okay? In this case, the middleman is 180, right? Equals 180. That's the middleman, so we can totally cut that out. And now what's happening here? So again, we're done with the diagram. Let's look at what we're working with here. We got this thing going on here. And now so we've gotten this far. Now take a look at what's happening. Remember what we were supposed to prove? That angle 1 is congruent to angle 3. So we have to have angle 1 and angle 3 somewhere together. Take a look at this line. Now we have angle 1 over here and angle 3 over here. They're together, so let's do a thing. If we were solving an equation, right, what would we do here? You know what we could do? We could subtract the measure of angle 2 from both sides. So we could be thinking, right, we could be thinking minus the measure of angle 2 here, minus the measure of angle 2 there. We could be thinking that, and then our next statement would be, well, if that's the case, then the measure of angle 1 is equal to the measure of angle 3, right? And then what did we do? How did we get there? We got there by using the subtraction property of equality. Okay? So we don't have to state that we subtracted the measure of angle 2. We can just do it, right? So it's the subtraction property of equality. Now you might be thinking we're done, right? Oh, yay, we're finally done. Ha. But then you got to be careful, be careful. What we're supposed to prove is that the two angles are congruent. All we've said so far is that the two angle measures are equal. So we have to finish this, right? We got to finish it. This is how.
Good afternoon, Cougars. All Cougars who are not in after-school supervised activity, please exit the iron gate. If you are part of a supervised after-school activity, you need to get with that faculty member immediately. Thank you. Have a great day.
Now, if you haven't guessed on our campus, we love you all and wish you would stay here as long as you can, or not, get out. But anyway, back to the proof. So how do we finish this thing? We're looking to prove that two angles are congruent, right? So if their measures are equal, then the angles are congruent. So we have to say angles with equal measures are congruent. Right? So we have to use that, that statement. Now we have proven, signed, sealed, delivered, that angle 1 is congruent to angle 3. So we know now that vertical angles are congruent. So what we can now say, is this. Here's what we have established. We have established this. If we have vertical angles, right, then the angles are congruent. Okay, that's what we have established, and that is a theorem. Okay, so that is what we have established. If we have vertical angles, then angles are congruent, and that is our vertical angles theorem. Vertical angles are congruent. Okay, which is different from a postulate. Postulates are just defining vertical angles. Postulates define congruence, but postulates don't make that if-then statement. Okay, so here we have our theorem. Vertical angles are congruent. Okay, so postulate would define angles. Postulate would define congruent. Theorem says if this, then that. Okay, so that's the difference anyway. So that was what you didn't see on the PowerPoint. So moving on to the next thing we're going to be working with, you'll find, how do we use the vertical angles theorem? So what does that look like? And then we have a couple of examples that I'll run through. Well, vertical angles look like this, okay? And we have this particular thing, and what we're going to say, what is the value of x? And so we have this picture, this diagram. So hopefully you realize what we're doing is looking at vertical angles. And what we know, with vertical angles, we have an equation, okay? So vertical angles bring an equation. Since vertical angles are congruent, their measures are equal. Okay, so the measures are equal. So the measure of this angle is 2x plus 1, or 21, and the measure of this angle is 4x. Okay, so that's what we've established. And so we're using the vertical angles theorem. And now we are ready to find the value of x. We have some basic algebra. So just like before, we have x's and 1's. And our 1's are already established here on the left-hand side. So we're going to move our x's over to the right-hand side. So we undo 2x. And we undo 2x by subtracting it, right? Or using the subtraction property of equality. And then here we use the division property of equality. And we end up with 10.5, right? So be it. So the value of x happens to be 10.5. So here we use the division property of equality, right? And so maybe I'll put that, division prop equal. So that way, instead of showing work, we can prove it that way. So what is the value of x? X is 10.5. And signed, sealed, delivered. And that's how that one works. Okay, so that was on the PowerPoint. Next, right? That was easy. So we jumped to the next thing that was on the PowerPoint that wasn't quite explained. And here it is. Right? So the next thing here, what is the value of x? Right? So hopefully you're doing this already. Again, they're vertical angles. Vertical angles make an equation. So 3x on one side and 2x on 40. 2x plus 40 on the other side. Okay. So this is nice and easy and super simple. We have x equaling 40. And what did we do? We used the subtraction property of equality. Okay, we subtracted 2x on both sides. Now we have 1x on the left-hand side. And so we have that all set. So it's nice and easy. So we're just using the vertical angles theorem for finding the value of x. Okay, so that's how that goes. That was on the PowerPoint as well. Now we have another thing on the PowerPoint, another proof. So now we're going to prove. Using a proof. Now we're going to use the vertical angles theorem in a proof, because once we established it as a theorem, we can totally use it. Okay, so again, if we're going to have a proof, remember, a proof with two columns anyway, a proof will have a statement and a reason. Okay, so statement here, reason there, bloop, bloop, and then that's what we're going to use to to prove this little thing that angle 2 is congruent to angle 3. So again, how do proofs work? If you don't remember, let's start with what's given. What's given, it says, okay, angle 1 is congruent to angle 4. And what's the reason? Well, it was given to me, right? Totally given. We could use that. And now we look at what's going on here. Blah, blah, blah. So I have angle 1 and angle 4. What's going on in this diagram? What's happening? We have some linear pairs here. We could start playing around with linear pairs, but it's going to be hard to do that. Excuse me. So it's going to be hard to work with linear pairs. Another thing we're looking at are vertical angles. Remember, we established vertical angles theorem, so we can use it. Let's use what we've established now. So we can look at either set of vertical angles. Let's just start with angle 4 and angle 2. So we can go ahead and say, well, that angle 4 is congruent to angle 2. And how do we know? What's our reasoning behind that? Because now that we've established the vertical angles theorem, we could use it. We could say, well, vertical angles are congruent. Okay, we can say that because we've established that as truth, right? So vertical angles are congruent. So we've said that, right? So I got my angle 4 and angle 2, and we need to get to angle 2 and angle 3. So now I got to look at this thing, and I have to establish something about angle 3, right? What can I do with angle 3? And you see what's going on. Again, we could use linear pairs, but it's not going to get us anywhere. Let's use that vertical angles theorem again, right? So let's take a look, right? Let's take a look at angle 1 and angle 3. So if we look at angle 1 being congruent to angle 3, again, the same argument. Well, vertical angles are congruent. Okay, so we can say that. Okay, so now we can look around at a couple of things. So check this out, right? There's a neat thing that we're about to do, and hopefully you can catch on. So we've established this congruence, right? 1 and 3 are congruent, 2 and 4 are congruent. But what did we start with? We started with 1 being the same as angle 4. So you know what we can say? We can look at this line here, this top line here. If angle 1 is congruent to angle 4, then we could use substitution right there, right? We can say that angle 1, right? Angle 1 now is congruent to angle 2. How do we know? Because I switched out that 4, right? Because angle 1 is congruent to angle 4. Well, angle 4 is congruent to angle 1, so I can call that angle 1 being congruent to angle 2. And that, if you remember, is called substitution. So I've basically substituted angle 1 for angle 4, okay? Now you hopefully see the end, because what's our whole goal? To prove that angle 2 is congruent to angle 3. That's our whole goal. We want to prove that. And so you're looking here, God, I feel like I'm so close. I got to get the 2 and the 3 together, right? You're like, what do I do here? Guess what, dudes? Transitive property will set you up for life. Angle 1 is the middleman now, right? Angle 1 congruent to angle 3. Angle 1 congruent to angle 2. Well, cut out the middleman. Cut out angle 1. And we can totally say that angle 2 is congruent to angle 3. And how can we say that? Transitive property of equality. Okay? So transitive property of equality. And we can now say that. And guess what we have established? We've established that those two angles are congruent. 2 and 3 are congruent. So if angle 1 congruent to angle 4, then 2 is congruent to angle 3 in this particular case. Right? So that's interesting. So if a linear pair, time out. If a linear pair consists of 2 congruent angles, well then the other 2 are congruent as well. We'll get there later. But anyway, that's how that one goes. So that's also what was on the PowerPoint that wasn't really explained very well. And so the last thing that I want to touch on from that PowerPoint was the question about writing a paragraph proof. So how does a paragraph proof work? And I just want to show you this. Okay. So the instruction was to write a paragraph proof for the vertical angles theorem. And if you remember, the vertical angles theorem was the first thing we did, right? Remember that? Vertical angles theorem? It was the first thing we did on this note. So how would that work in a paragraph proof? So I went ahead and typed it out. I just wanted to show you what this is because I'm going to be asking you about it later. Okay, this is coming back, folks. You're not going to escape this. And it's not just because, well, I had to do it in college, but in college it was just fun. I had all my proofs had to be done in paragraph form. So remember how this works. So this is if you don't remember that vertical angle theorem for this video, stop here, rewind, go back to this proof, and I'll show you what's going on. We have our statements and our reasons. For a paragraph proof, really all you have to do is consider saying the statement and then writing because and then giving the reason. Well, I can start, well, angle 1 and angle 3 are vertical angles because it's given. And that concept is how you can take a 2-column proof into a paragraph proof. The rest is grammar and writing styles. I'm telling you, the rest is grammar and writing styles. So here I would say angle 1 and angle 3 are congruent because that is given. Angle 1 and angle 2 are supplementary since they are a linear pair, right? Instead of saying because. The measure of angle 1 and the measure of angle 2 add to 180 because of the definition of supplementary angles, right? Then angle 2 and angle 3 are supplementary since they too are a linear pair, right? And then the measure of angle 2 and the measure of angle 3 add to 180 because they are supplementary. So right there in paragraph form, I've established these two equations, right? I've gotten this far establishing those two in paragraph 4, right? And then I put the big the big whopper on there. It's all, now you can play around with writing styles. Due to the transitive property of equality, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Okay, so basically I just wrote this line, but I said due to the transitive properties. This is where writing styles comes in. Could you have written this and said because the transitive property of equality? Yeah, you can. But let's work on our writing as well, right? And then again, I play around with it. When using the subtraction property of equality, it is clear that the measure of angle 1 is equal to the measure of angle 3. That's what I wrote here, right? You can totally do that. And then you put the final kibosh on it. You say, well, since angles with equal measures are congruent, angle 1 is congruent to angle 3. We've established the two measures are equal in the previous sentence, and then bam, we finish it off, and you can write mic drop at the end. Blah blah. So I really enjoy paragraph proofs. It's fun, and it helps. To be honest with you, folks, you may not believe me. This will help you with your writing style. It'll help you with your writing. It'll help you with your speaking. So there's many things that come of taking a 2-column proof and turning it into a paragraph. Is a very, very helpful skill. You're going to find it tedious. You're going to think, oh, Mr. Katz, this sucks. But do it anyway. And that's it. That's it for the supplement here for the PowerPoint notes that are on Edmodo. And hopefully you're ready to roll with this little unit. It's a small unit, and hopefully it will start fine-tuning the way you think and the way you argue and the way you put together your communication skills. And if you're like me, it'll help you a lot with communication. I used to be shy until I did this. Yeah, but you didn't know that. All right, enough rambling for now. I'm out of here.